Hey guys, let's go ahead and look at the product property of logarithms. I know it says up here that we're going to look at quotient, but that will be in a different video. Well, let's go ahead and take a look at this. The main thing you're going to need to understand is the basics of what an actual logarithm is. And I have that shown right there, that the log base b of x equals y. Once we understand this, we can go ahead and derive this property with just a little intuition. Let's go ahead and take a look. So in this process, we have a base b, and we're going to use it for both terms. And then we need to consider our log base b of x and our log base b of y, which I have written down here in different colors. And we're going to go ahead and let log base b of x be some value like m. And we'll let log base b of y be some value such as n. Now going back to what an actual logarithm means, let's go ahead and see what this would give us in exponential form. So we have a base b to the power of m would equal x. And likewise for log base b of y. So the only difference with these two is that we have different powers of base b, and they just equal different letters there, x and y, which are going to be in our final property anyways. Let's go ahead and look at x and y, because right here they're multiplied together, right? So let's go ahead and multiply those together. X times y. And what would this equal? Well, it would equal base b to the power of m times base b to the power of n. Well, using properties of exponents, which in this case is just the product rule, since we have the same base, we can go ahead and add the two exponents. So that kind of simplifies the exponents, but we know this should equal some base value b. So if we added m and n, which we don't know what those values are, so we will also need another variable to represent what they are when they're added together. This allows us to use the uniqueness of base b to the power of x, which allows us to solve an equation where we have unknowns like we do right here. So we'll just go ahead and make b to the power of, we'll just make it r. Okay, so it's a little bit different than the other letters that we've been using. Well, looking back here and using the x and y, we can actually write r as a logarithm. So all I've done here is moved b to the power of r over here to the left side, which will allow us to write this b to the power of r equals xy as a logarithm. And there's our logarithm there in green. Now going back to the uniqueness of b to the power of x, we can write an equation using just the exponents right here. Let's go ahead and do that right now. And some of you see what's happening here. We have an r here and an r there, which we're going to be using some substitution there. And just to make it so that it's going to come out in this form, let's go ahead and move this r over here to this side, so r equals m plus n. Well, then from here we just need to look back. What is m? Well, if we look back here to this m, it's log base b of x. Alright, that's fine, but what is n? Again, we're going to look back here as to what n represented in the beginning, which is log base b of y. And those are added together, as we can see from this operation. And finally, just looking at what r is, again, I can just take this log and move it over here, which I will do now. And finally, we end up with the property that we sought from the beginning. So this may not be something that you would do on your spare time, but just in case you were curious, this is how we get this property, the product of logarithms. Alright, well, thanks again for watching. Please subscribe to the channel, and in a different video you'll see the quotient property of logarithms. Have a great day.